In Season 7 of The Secret of Skinwalker Ranch, the investigation team began to suspect that the answers they had spent years searching for were not on the surface at all. They lay beneath it. Somewhere on the southwest quarter of the property, a tunnel had been opened, used, and then sealed shut, decades before anyone currently connected to the ranch had ever set foot on the land. The team's archive held a single clue, an old survey, drawn by hand in faded ink and dated 1908, that referenced a sealed shaft in that exact region of the mesa. From that single page of brittle paper, an entire season of methodical work would grow. Longtime neighbors had spoken of a tunnel that was closed off sometime in the early 1940s, sealed because the original homesteading family no longer felt safe entering it. Those neighbors were now elderly. Some had passed during the years since their first accounts were recorded. Their recollections, gathered carefully by a graduate research assistant assigned to the project during Season 4, described not one entrance but two, a smaller ventilation collar on the upper slope and the larger shaft entrance below, both of which had been collapsed together in the same season of work. Aerial photographs taken in 1947, only recently rediscovered in a state archive in Salt Lake City after a routine recataloguing effort, showed the faint outline of a surface collapse in that same corner. The collapse had been filled in with soil long before the ranch changed hands. For years, those photographs sat in a folder marked only with a date and a parcel number. Now they had a location. The team returned to the southwest quarter more often after that discovery, but with restraint. The ground there has the particular quiet of places where animals do not bed down at night. Cattle avoid it. Horses walk a wide path around it. No one on the team was eager to be the first to say why. One of the ranch's longtime ranch hands, asked off-camera about that section of the property, paused before answering that he had learned, early on, not to ride through it after dark. He added, after a longer pause, that his grandfather had felt the same way about that exact stretch of ground in the years before the present owner ever arrived. He could not remember who had told him that. He remembered only that the warning had been given. The coordinates in that photograph lined up almost exactly with a small patch of ground that the team had learned not to ignore. Across 7 seasons of measurements, that single low-lying corner had produced readings that refused to behave like the rest of the property. The patch sits in a slight depression where runoff collects after storms, ringed by sage and a few hardy juniper whose roots twist in odd directions, as though they had been shaped by something beneath them rather than around them. To the untrained eye, it looks unremarkable. To the team's instruments, it is one of the most consistently unusual points on the entire mesa. A magnetometer cluster, deployed in the closing weeks of Season 6, had captured sharp, short spikes on 3 consecutive nights. Each spike timed to broadband, low-frequency interference that briefly drowned out the team's own radio transmissions. The spikes came in clusters. They lasted, on average, 4 to 6 seconds. They always occurred at night, between roughly 2 and 4 in the morning, and they always occurred when no team member was physically standing near the array. The team's electronics lead walked through the data alongside the principal investigator on a cool October evening, both of them watching the readings replay on a laptop balanced on a folding table inside the trailer. Neither could offer an explanation that satisfied both of them. He paused the trace at one spike and pointed at the waveform without speaking for several seconds. "That's not wind on a fence," he said finally. "That's not a truck. That's under us." The principal investigator nodded slowly and asked him to walk the trace back, frame by frame, while he wrote the timestamp down in longhand. By morning, that timestamp had been written into the corner of 3 separate working notes, and the camera crew had been asked to schedule a return visit to that exact patch during the next available weather window. A thermal sensor installed at the same point had recorded a cold anomaly of roughly 2.5 degrees below the surrounding soil, and that anomaly had not moved. It persisted through summer heat and winter freeze alike. In August, when surface soil temperatures on the mesa reached the mid-30s Celsius, that corner reads 2.5 degrees cooler than the lowest comparable control point. In January, when the same soil reads -10 on a calm night, the flagged corner is still 2.5 degrees cooler than the control. The relationship is precise. The relationship has held across every season of measurement the team has run, without exception. A spectrogram captured noise at 137 kilohertz, a frequency the team had spent years trying to attribute to something ordinary. Local transmitter maps showed no matching source. Atmospheric monitoring stations within 200 miles showed no comparable reading. Whatever was producing that signal was local. Whatever was producing it was below ground. A visiting electrical engineer, brought in to consult and given nothing more than the raw spectrogram and the site's coordinates, sat quietly for a long time before admitting that the trace did not match any infrastructure she could locate in her survey databases. She asked, in a careful voice, whether the team had considered the possibility that the noise was not originating from any human-built source at all. She was told that the team had considered many possibilities. She was not told yet what the team believed. She left the consultation with a printed copy of the spectrogram folded into her notebook, and the team noted in the project log that she had asked to keep it. The principal investigator underlined that note in his own copy as well. The team reviewed the archived sensor logs in full resolution, an exercise that took weeks of careful work. Each spike was correlated with barometric pressure, with solar activity, with the position of known satellites overhead at the time, with the schedule of regional commercial radio broadcasts, with the on-site presence of personnel, and with the lunar phase. None of those correlations held. The spikes occurred when the team was away from the site. They occurred during quiet weather. They occurred during periods of low solar activity. They did not respect the working week. Pattern recognition gradually confirmed what earlier seasons had only hinted at. A single location on the property produced repeatable anomalies without a known cause, and the rest of the mesa did not. Some scientists on the team leaned toward the possibility of forgotten Cold War infrastructure, buried and forgotten here, as it had been buried and forgotten in dozens of other places across the American West. Magnetic resonance, low-frequency hum, a confined underground space, all of that fit a familiar story. The difficulty for them was the persistence of the signal. Cold War infrastructure tends to rust. It does not, 80 years later, continue to broadcast. The team could not yet rule that explanation out. They could only say that no working model of that hypothesis had yet explained everything they had measured. A visiting geophysicist, brought in to advise and given the season of logs in summary form, suggested at the end of the review that the team consider, however reluctantly, the possibility that some readings have no clean natural cause at all, and that the absence of an explanation is itself a form of data. The decision to commit a full season's centerpiece investigation to that single point was not made quickly. Ground-penetrating radar was run across the site in a tight grid, the operators walking slowly back and forth across the flagged area, with the receiver held steady at the same height on every pass. The current scheduler moved the survey to the early hours of the morning to keep sweep noise from the team's own generators out of the data. The resulting profiles showed a striking feature, a vertical density gradient directly beneath the flagged location. The signature was consistent with a shaft descending into bedrock, narrow and straight, and it had been waiting under the disturbed soil for a very long time. The shaft appeared as a clean vertical column of low reflectivity against the surrounding sandstone matrix. The walls of the column were tidy in a way that natural voids almost never are. A careful test excavation uncovered the edge of a concrete cap. The cap itself was undisturbed. The first fragment brought up onto the surface had a particular weight to it that older ranch workers on the team recognized immediately. Aggregate samples from the cap and a partially legible stamped date on the embedded metalwork pointed to a construction era around 1943. Independent research in the Uintah County Historical Society confirmed that the site had indeed been called, simply and unremarkably, the Old Shaft, in ranch transfer paperwork from the late 1940s. The phrase carried the quiet weight of something the family did not wish to discuss. A clerk at the Historical Society, asked to pull the file a second time for cross-checking, volunteered, without being asked, that her own grandfather had worked on a job of that kind somewhere in the basin in the same years. She could not say more. The lead archivist, consulted later by phone, suggested, gently, that certain wartime projects left no paper trail by design, and advised the team to be careful in whom they trusted with their inquiry. The team filed that observation alongside the photograph of the cap and moved to the next phase of planning, agreeing first that no member of the team would share those archival responses with anyone outside the project without prior review. At this stage in the project, the questions became procedural as well as scientific. What authority did the team have to open a sealed shaft beneath land that was not theirs? Could the opening be done safely? Could it be done in a way that preserved every layer of the seal for later study? Engineers were consulted. A petrographer confirmed the dating of the aggregate to within a few years, noting that the cement chemistry itself pointed to wartime-era supply constraints on the Colorado Plateau. A methodical plan was approved. The cap would be cut, lifted, cataloged layer by layer, and stored. The shaft itself would not be entered until the cap was fully understood. Everyone on the team understood that this kind of opening is irreversible. Once concrete is broken, the original historical seal is gone. Whatever the seal had been designed to keep out or in would from that moment forward be on its own. The structural engineer who supervised the cut noted later in the operations log that the team had spent more hours planning the opening than they would spend performing it. That asymmetry was deliberate. The team agreed, before any cutting commenced, that no segment of the original seal would be discarded. Every fragment lifted from the ground went into a numbered crate, in order, before the next fragment was touched, and each crate was photographed in place before being moved. The cutting of the cap took longer than expected. The team's structural engineers had assumed a single pour. They found three separate layers, poured in 3 separate visits by what appeared to have been the same small crew. Each layer had its own texture under hand lens. Each layer had its own slight curvature at the edges where the formwork had been reset. Between the second and third layer, a thin but unmistakable seal of bentonite clay had been added, a material no private rancher would have chosen for an ordinary well, root cellar, or natural sinkhole in austere rural Utah. Bentonite is engineered containment. It is the material used in landfill liners, in environmental remediation, in places where something is being kept away from groundwater rather than simply being kept out of sight. Photogrammetry of the layers showed each pore as its own surface, distinct in texture and slope, and what might once have been a single decision now read as a sequence of escalating decisions. Something, someone, had changed between the first layer and the last. The team stood around the cut cap in the thin morning light and let the implications settle in silence before continuing. The structural engineer ran a palm across the bentonite seam and asked, quietly, what the ranch had feared more than water. Nobody on the team answered, but nobody walked away either. The bentonite sample was bagged, sealed, and placed into a cold storage container the team had brought up for exactly this purpose. The principal investigator logged the engineer's question under the heading "Open Question" and placed it at the front of the planning binder where it would be seen at every subsequent meeting. Inside the seam of the second layer, the team found a small folded piece of paper wedged against the bentonite. It was a note, handwritten in pencil, dated 1943. The handwriting was unpolished, the work of someone accustomed to ranch labor rather than correspondence. The note described sounds heard at night near the shaft, sounds that would not settle, sounds that were never quite explained even when the wind was calm and the cattle were quiet. The note also described a refusal to enter the shaft at night, and a rule passed down among the local ranch hands that the descent shaft was to be approached only by daylight and never alone. There was no signature. Independent handwriting analysis by a forensic document examiner identified the hand as consistent with farm worker records from the same period held in the same county archive. The note was genuine. The team tabled several working theories at once. The author had been inside the shaft. He had heard something he did not understand. He had chosen to commemorate that experience in the only durable way accessible to him, by tucking the note into the seal he was helping to build. None of the team members who read the note aloud that morning could say, with documentary care, what the sounds described actually were. The note was photographed under raking light at 6 magnifications, transcribed by 2 independent reviewers, and entered into the archive under the heading "Personal Account, Unsigned." It was the smallest document the team had ever admitted into evidence, and the one that sat heaviest on the table. The principal investigator, reading the note aloud for the record, stopped twice to ask for water before continuing. The camera crew present in the trailer that morning recorded every reading, and the audio of that recording has since been entered into the project archive under restricted access, available only to credentialed reviewers and members of the working team. The descent was prepared with redundant safety protocols. A tethered rig carried cameras, lights, calibrated thermal sensors, and air sampling equipment down through a small opening cut into the 3rd layer of the cap. The shaft descends at a nearly constant 5-degree angle for the first 40 meters. The walls are hand-cut sandstone. The tool marks are uniform and unmistakable, the work of 1940s-era manual mining labor, executed by a small crew familiar with the local stone. The marks are evenly spaced. They show the rhythm of a practiced hand. At 15 meters, an unusual observation began to register on the thermal sensors. The air temperature stopped falling. It began to rise, gently at first and then steadily, until it held at 14 degrees Celsius and stayed there. The surface temperature on the day of entry was well below freezing. The 2 readings refused to agree, even though they were separated by only 15 vertical meters of solid sandstone. The team lowered 2 more sensors at staggered depths and watched the readings converge on the same number. Whatever was holding the chamber at 14 degrees was doing so with a confidence that the surrounding geology could not, on its own, explain. One of the structural engineers asked over the radio whether sandstone at the depth and density of the surrounding rock could store and release heat in that pattern, answered after a long pause that it could not, in any model she trusted. The camera feed in the trailer showed the team nothing dramatic, only pale, smooth walls and the slow progress of the tether. But the temperature trace on the monitors told a different story, and the operators were quiet as they watched it. One of them, a senior descent operator with 2 decades of mining experience, said afterwards that he had descended hundreds of shafts in his career and had never seen a thermal profile behave that way without mechanical intervention. Air samples were taken at 5-meter intervals and sent, without comment, to an independent gas chromatography laboratory. The results returned in 11 days. A faint hydrocarbon signature was present in air drawn from below 30 meters. The signature did not match the surrounding geology. It did not match any known hydrocarbon deposit within miles of the mesa. It did not match a biological decay profile. It did not match surface contamination. 3 credentialed reviewers examined the chromatography results. 2 concluded that the signature was consistent with trace atmospheric hydrocarbons migrating from a deeper geological source along microfractures in the sandstone. The 3rd concluded that the signature contained structural markers of a synthetic, manufactured origin, and asked, in writing, whether the team could verify the seal integrity of the sample containers used in transport. The team replied in writing that the seal integrity had been independently verified by the laboratory before analysis. The disagreement was honest and unresolvable with the data at hand. The team logged both interpretations. They did not resolve them. They recognized that bringing in a 4th and 5th reviewer would not, at this stage, change the underlying data. The principal investigator asked at a planning meeting whether the team believed the signature was natural, answered that the team believed the signature was real, and that believing more than that would be a misuse of the word. The lead chemist, asked separately, noted that the textbook would have to be rewritten in either case, and asked which part of the textbook the team would prefer to overturn first. Nobody in the room answered that question on the record. At 47 meters, the shaft opens into a roughly circular chamber 8 meters across. The ceiling and walls of this chamber are unusually smooth,